Okay. I think we're ready to go. Okay. Thank you everybody for attending tonight. Hope you've had a nice summer break, summer recess. So we'll start the programme again now up to Christmas. Tonight we are delighted. I mean, I'm always an advocate of having an active committee. So it's great when we see John, our committee member, coming to give us a talk as well. So John Batty from TransPennine Express is going to give us a talk on ETCS, digital signalling and train control in the north. Obviously, a very up-to-date topic for what's going on the TransPennine route upgrade, East Coast Main Line, and the general direction for ETCS implementation in the UK. So I'd just like to ask you to attend to your phones, make sure they're on silent, and if you've got any questions, we'll have them at the end. And I think that's it really. Without further ado, over to you, John.
Thanks very much, Lyndon, and good evening, everyone. So as it says there, I'm John Batty. I'm the head of digital ERTMS for TransPennine Express. I'm assuming quite a lot of you will know what ERTMS is, but there will be a bit in my presentation where we'll just cover some of those bits there. So today I'll give you a bit of introduction about myself and TransPennine Express, the company I work for. What is ERTMS and ETCS? Hopefully this will be a bit of a refresher for some people. Some people might be the first time, so we'll go through that. We'll then talk about the ETCS deployment in the north and the ones that are impacting TransPennine Express as an operator. We'll talk about TPE's approach to upgrading our rolling stock. And then finally, as it is a technology-driven sort of program project, we'll then talk about how we're actually going to prepare our sort of staff and colleagues to be able to utilise the system. So a little bit about myself. So I joined the railway in 2013 as an engineering graduate for First Great Western at the time. I did a couple of engineering roles, maintenance roles there, so I spent some time in the tech office at Reading Train Care Depot. I then moved into engineering projects where I was the engineering lead for the Class 387 introduction into Great Western Railway, so that was the 45 Class 387 Electrostars. And then a continuation of that project was the GWR Heathrow Express project, where because of HS2 and the desire to close the Siemens depot at Old Common, a plan was made up to convert 12 of those Class 387 trains for the Heathrow Express service, and then so I was the engineering lead for that. The relevance for this topic is that as a project we installed the Bombardier ETCS onboard system onto those trains. Those trains went into service in 2020 and have been operating with ETCS since then. Then I was a stint as in depot management as a senior production manager, and then I'm actually from Greater Manchester myself, so a chance to do some more ETCS, which I'm quite interested in and passionate about, came up, and so I moved up to TransPennine Express 4 years ago as engineering project manager, and then more recently, in the sort of last 2 years, I've become the head of the team there. So just a little bit about TransPennine Express. I'm assuming most people know about ourselves as an operator, but we're an intercity operator in the north of the country. We operate in the north of England and into Scotland. We serve a lot of those locations you see on there, and it's pretty shocking I've not actually been to all of them. But in terms of key routes that we operate on, we have our Anglo-Scottish route, which runs from Liverpool Lime Street and Manchester Airport up to Glasgow and Edinburgh, the West Coast Main Line. We then have our north route, which is sort of Liverpool via Manchester, Leeds, York, and up the east coast to Newcastle and Edinburgh. That's where the TRU route, the TRU TransPennine route upgrade is on that line of route. And then finally we have our south route, which is Liverpool via the CLC to Manchester Stockport, Sheffield Doncaster, and out into Lincolnshire. We've got about 1,800, 1,900 employees. We operate sort of 19 stations, and we're talking about 27.5 million passenger journeys a year on ourselves as an operator. So moving on to ERTMS and ETCS. I was hoping to share a video with you, but I can't seem to get the sound to work. So as opposed to showing you that, I'll just talk you through the current elements. Okay, as I said, background's more rolling stock engineer. Appreciate I'm talking to the RSE, so there might be, so in terms of signalling, there's obviously clearly some experts here in the room and on the call, but we'll just go through the current state of signalling today and where we're trying to get to with ETCS. So currently we have sort of a conventional signalling. So on the diagram there we've got sort of 4 aspects. We've got 4 aspect colour light signalling there. The railway is split up into signalling blocks, and this is how we keep trains safely apart from each other. In this scenario, in this sort of configuration, the driver looks out the window, sees the colour of the light in front of them, and based on that they will sort of manage the speed of the train in response to that. As just relying on the driver, just looking at those signals and reacting isn't adequate enough. We currently use train protection systems in the form of automatic warning system and the train protection warning system. So just on the diagram there, we've got an ADRS magnet, which will provide an alert to the driver if they're approaching a cautionary or red aspect, and some other situations where the driver has to cancel. If they don't cancel it, that will put a brake intervention. That will initiate a brake intervention on the train. And then beyond that, we've also got the train protection warning system in the 2 configurations of sort of overspeed, where we've got the TPWS transmitters. If the train speed is deemed to be too high, there'll be a brake intervention, bring the train to a stand. And we also typically at red signals have sort of train stop system, where if a train passes through a red signal and creates a SPAD, then obviously that's the train brakes are applied, the train blocks will stop. Unfortunately, depending on what speed the train is going at the point it passes the red signal, that train can potentially continue going as the brakes are applied to a point of danger. Just in my sort of research for these points, I think it's ADRS has been, or forms of ADRS have been around since the early 1900s, and sort of TPWS was really brought in TPWS was really brought in around the early early 2000s in response to the significant rail disasters of sort of Ladbroke Grove and Southall. It was meant to be a temporary solution because ETCS was supposed to be rolled out and delivered. We're now in 2025 and we don't have as much as of the network sort of deployed with ETCS yet, but hopefully I'll explain to you where the industry is and where we're going with it. So what is ERTMS and ETCS? So ERTMS stands for the European Railway Traffic Management System, and it's part of the rail industry's plan to transform the railway for rail users and deploy sort of digital in-cab signalling to enhance safety, improve capacity, reduce delays and drive down infrastructure costs. This digital technology will be delivered as part of TransPennine route upgrade, and also it's planned to be part of the West Coast Main Line modernisation scheme. There are 4 main components to RTMS. There's the train control element, ETCS, so the European Train Control System, which will be the focus of this talk. There's also the GSMR network that we currently use in this sort of voice configuration for typically train drivers to speak to the signallers. There's operating rules, aka the rule book, and then there's also traffic management, which is looking at how we can manage traffic better on the network. So I'm not going to go through all the different varied levels and modes that ETCS can operate in, but in terms of this presentation I'm mainly going to focus on ETCS level NTC and ETCS level 2. So just a bit of an example. So ETCS level NTC, that stands for National Train Control. On the GB network, our train control is ADRS and TPWS. And what level NTC simplistically is the operation of ETCS fitted trains on conventional infrastructure. So what I've done on here is, so one of the key elements is regards to ETCS is the introduction of a DMI screen in the cab for the driver. And then what level NTC will then allow that driver to operate the train as they do today with ADRS and TPWS protection, but there are different sort of formats that can present to the driver. Either it will just be the speed is on the DMI in front of them, and they'll use separate sort of ADRS and TPWS hardware for those indications, or potentially some ETCS solutions will have that integrated onto the DMI itself. Those examples there. So once we've got ETCS level 2 infrastructure, we can then have ETCS level 2 operation. ETCS level 2 signals away will become the sort of level of operation for ETCS on the GB railway. Over AWS and TPWS, which are Class B safety systems, ETCS level 2 provides continuous speed supervision to the train. The train knows where it is, the signal system knows where it is, and with the use of those yellow Euro balises that contain data, the train can be continuously supervised, and therefore it's a Class A safety system, so safer than AWS and TPWS. The other benefit is in this configuration where the train is continuously talking to the radio block centre by the GSMR network, is that we're in a position where we can remove colour light signals, which has lots of sustainability and maintainability benefits. One thing that, when a train is operating under ETCS, the signal system can provide a movement authority to the train. This gives the train permission to a specific location, and it also provides a speed profile for that train to move at to get to that location. Should the train speed exceed the braking curve or the speed profile that's been provided, the ETCS system can intervene by providing the driver with visual or audible warnings. It can also cut traction power to the train, and if the train speed isn't controlled at that point, it can then provide brake interventions to bring that train to a stand before it goes to a point of danger. Just to try and show you what this looks like to a driver as it's presented to them in the cab, here is a ETCS DMI showing some ETCS information. So as you see the speedo there, the grey line around the outside is the speed hook, so this will tell the driver the maximum permitted speed. It would also, via this speed hook, provide information of changes of speed and also how much the driver needs to brake. There's other elements where the screen will tell you what ETCS level you're in, which mode you're in. There'll be some text messages that will give you information around mode you're entering and also potentially locations. But the other key element of ETCS level 2 is that the right hand side of the screen, known as the planning area, this can provide information of how far that movement authority is, how far ahead the track is clear, changes in speeds, ends of authority, and also things like gradients. So how do we get from a migration of the conventional railway we've got today? So firstly, with ETCS fitted trains, they can operate in level NTC over that route. Apologies for some of the terminology, lights on sticks, that's something my boss often says, but essentially it's how we operate the trains today, conventional signalling, and we're using that ETCS fitted train. When the infrastructure managers, so Network Girl, get to a point where they can install ETCS infrastructure onto the line, we then go to something called ETCS with signals, or colloquially known as ETCS overlay. Here we've got both the conventional signal system and the ETCS system on top of each other, and therefore if your train isn't fitted or you're a driver that isn't trained, you would just drive as you were on the top line. However, if you're in training or you are competent, you'll just transition and use ETCS level 2 and start to get some of those benefits mentioned before. Once all the trains are fitted, once all the drivers are trained, the infrastructure manager will be in a position to remove the colour light signals. And so the third line there, we've got ETCS level 2 signals away. Excuse me. And there we've obviously removed all those line side assets and all the associated elements there, so you actually get the benefits of the ETCS system at that point. And then finally, from the sort of third line and the fourth line, the only physical infrastructure on the network will be the train detection element, and therefore you can then start to optimise the layout in terms of train detection. Also, because the train sorry, I should have said that the movement authority is also based on the braking characteristics of that train. It means that actually trains can run more safely closer together. Just to try and further demonstrate what benefits ETCS can provide is just with this diagram here. where I think conventionally when a driver sees a double yellow or a single yellow, they would be braking in anticipation that they're being brought down to a stop at a red signal. If we think in particular of the, so basically driving on site, that's what they'll do and we'll see. With ETCS, the system will allow that driver to brake later because of the braking performance of the train. This also has added benefits in terms of, with colour light signals, the driver has to physically see that signal. So if we think about the line of route between Stalybridge and Huddersfield, and the TRU route, it's quite windy, it's quite bendy. You could be driving in poor visibility, that you might be being brought down, or you might be bringing the train, controlling the train to be bringing it down. The signal could be clear, and it's only when you come around the curve that you notice that. Whereas with the ETCS system, as soon as that track section head is clear, the system will update and allow that driver to proceed at a faster speed. And then also, we mentioned that because you're doing it based on the braking performance of the train, you can obviously brake at a later point safely to a stand. There's obviously human factors, considerations that we need to review here, because if a driver's been braking at the same point all their career, there's obviously going to be a transition from them using the system at that point. So where do we currently have ETCS in the country? I've put on there the key deployments. So the first one was the Cambrian line, so from Shrewsbury out to Pwllheli and Aberystwyth. That was the sort of the pilot scheme. I think it was around 2011, and that's still in operation in an early version of ETCS. Other ones to note are the Paddington to Reading ETCS 0 to 12 miles ETCS deployment, which currently has ETCS with signals from the Acton area into the Heathrow tunnels, and sort of 387s, 345s operate those services. And then the schemes that you might have heard of are the sort of Thameslink operation in London, and also the Northern City lines. Thameslink has ETCS level 2 with signals, but also automatic train operation. And then the more recent one that's been in the news is that there's the Northern City line, so trains from Moorgate up to Finsbury Park, which have gone to that. They've removed the colour light signals on that part of the line, and that is the first part of the East Coast Digital Programme, which is the next large ETCS programme to go live, which will be on the south part of the East Coast main line. Following on from that will be the two programmes I'm going to talk to you about next. So after East Coast Digital Programme, the next deployments will be the TransPennine route upgrade, and then also, as mentioned before, the West Coast Mainline North modernisation programme. Focus of the talk will be on the TransPennine bit, but in terms of the West Coast Mainline North modernisation programme, they're planning to renew all the assets from sort of Crewe North to the Scottish border. As part of that, they plan to put ETCS level 2 infrastructure down there. So the TransPennine route upgrade to the TRU programme, I know the centre's had a couple of presentations, so lectures from there, but just as a reminder, if you're not aware of it, it's a multi-billion pound railway programme that's there to better connect Manchester, Huddersfield, Leeds and York. It covers 70 miles of track. There's a bit of a diagram on the left there that shows how they've chunked up the programme to all the deliverable parts of it. TRU is there to deliver faster journeys, greener journeys, more reliable journeys, improved customer experience in terms of station environments, and also more trains with more seats. And in terms of time scale, so TRU is very much live at the moment, with Huddersfield being closed. They've already electrified, I think, 25% of the route. And in terms of a timeline, the focus of the rest of the decade is to doing all the conventional interventions, the electrification, the building of new lines, and then it will be in the early 2030s that we'll see some ETCS infrastructure delivered as part of that programme. Unlike traditional infrastructure programmes, TransPennine Express and Northern Trains as operators are in a sort of programme enterprise, and within that, so we are embedded in the TRU digital programme, where we're looking to get come up with the right solution to get digital signalling on that piece of route. As with all big programs and companies, there's a vision, a mission, etc. But I think the ones that really stick out for me is that the industry is trying to take a whole industry approach, a whole system approach, where we're focusing on the end users and we're making it people-centric. So what will ETCS deliver in the end? So there's the safety improvements that we talked about before. There's less infrastructure and less cost to maintain the infrastructure once it's been delivered. There's obviously sustainability benefits, and it will increase capacity, performance, and provide consistency and flexibility in terms of delivering by-die operation, which allows the train service to recover better in terms of perturbation, but also that provides opportunities for example, to carry out maintenance on one line whilst you keep trains running on the other. So where will ETCS infrastructure be put down on the TRU route? So between Stalybridge and Colton, which is just south of York, and the main areas will be Stalybridge to Cottingley, and then the east of Leeds station up to Colton Junction. Initially there'll be areas of ETCS level 2 with signals to facilitate driver training, and then the majority of this should be removed once drivers are trained, so that the full benefits of the system can be provided. So that provided the sort of what ETCS is, what ERTMS is, and also the sort of schemes that are driving our activity. But the next part of my presentation, it talks about sort of ourselves as an operator, how we approach the upgrade of trains, and then also the business change elements of our work. So you might see there that the infrastructure dates are into the 2030s, and you might think, well, why are you moving so quick to try and upgrade our rolling stock? I think our approach, our philosophy in TPE is to try and get fleet fitment done as soon as possible. And the reason for that is if you're aware of any other fitment programs, they often take longer than anticipated. So we want to start early. This adds other benefits in the case of we can get the kit fitted to the trains, we can get those trains into service and level NTC operation, we can iron out any initial reliability issues there, and it also provides a step to allow our drivers to get themselves familiar with any changes to the cab and also interacting with the system. It was a challenge that we had on the Heathrow Express project. Because there isn't actually TPWS in the Heathrow tunnels, we had to deliver the trains into level 2 operation straight away. And then we had some system reliability issues with those trains where, unfortunately, in the same journey, we'd have a level NTC issue at Paddington and then a level 2 issue at Heathrow at the same journey. Whereas with a staged approach, you can then focus on that level NTC issues, build some business resilience, and then obviously come along and tackle that level 2 further down the line. So when we look at fitting components onto our trains, this diagram shows the key components that we need to install onto there. So we've got the European Vital Computer, the EVC. This is the ETCS computer that controls the system on board the train. We obviously provide a DMI in the cab for the driver to interact with the system. As mentioned before, the way the train communicates with the signalling system is via a EDOR radio, so an ETCS data-only radio, which again uses that GSMR network. We need to install a JRU, so a juridical recording unit, which is essentially the OTDR, so the train data recorder for the ETCS system specifically. In order to read the passive balises, those yellow balises, we need to install a balise antenna so that can read those. And then because train position becomes more important as we need to accurately give that to the signalling system, we need to typically upgrade the odometry equipment on the trains. This is typically done with additional axle and speed probes, but also some ETCS solutions use Doppler radars as well. Just to give you a bit of a an idea of what those physically look like, so a bit of a scour of the internet of what those components are. If we look at the ones that are internal to the vehicle, typically they'll be installed in electrical cabinets and behind ceiling panels, so we don't want them in the passenger environment. And obviously on the frame equipment there is pretty standard. So in terms of a typical approach to our ETCS fitment on upgrades, we obviously start, as any project, with a contracting. We step through quite an intense design phase. We'll then run a first in class, which I'll come on to talk about. Once that first in class has the equipment fitted to it, they'll then be tested and there'll be lots of validation activities, and all this builds up the evidence for the technical file, which then gets submitted to the ORR, which I'll come on to. We'll then do some technical compatibility and put them to use to make sure we can use these trains in service, and once we've got all that secured, we can then fit the rest of the fleet and then also run these trains in ETCS level NTC operations described, and then ETCS level 2 once the infrastructure is there. Pretty basic stuff when it comes to engineering projects, but I just wanted to spend a moment just to mention some things about contracting, as it's from our experience it hasn't always been done to a great level, and it's something that we're obviously trying to address with our projects and fitments, is that we need to utilise previous fitment contracts that we've had and learn from them, but also making sure it's really clear who out of ourselves as an operator or a supplier is doing which roles, and also to make sure that we focus not purely on getting the kit onto the train, but actually how do we support the system once it goes live, how do we ensure things like training support, reliability growth are all covered. And it's quite a common theme where we're going to be focusing on the cab environment, and that's the main change to our drivers as an operator. On the right hand side, I just thought I'd put some examples of the different starting points that we face when it comes to upgrading our fleets, because as you see in the top one there, it's a mock-up of a Class 185 which doesn't have a DMI on it, so therefore it's quite an extensive modification to the cab that will need to be done to fit that screen in there, move some components around. But on the bottom is a GWR Class 802 which already has ETCS equipment on it, even though it's not operating in ETCS. The DMI is there, that's used to provide speed to the driver, but also the ETCS system is currently only being used to provide the speed signal, but also automatic power changeover and selective door operation. So hopefully you've done all that work where we've got everything agreed up front. We've reduced the risk of any ambiguity and sort of the scopes nailed down with our supplier. We'll then move into a design phase. I'll try to illustrate the sort of what the design changes are. So that's the Class 387 cab. So the top one's a modified one. The bottom is a modified one where you can clearly see there's been a removal of the old analog speedo, the TPDRS. HMI or DMI has been removed, and it's obviously been replaced with a DMI screen. This has also involved numerous elements and controls indicators of the cab to be moved, so all that needs to be properly designed and go through sort of human factors assessments. As with any design of this kind of modification, there's obviously mechanical, electrical, software design packages that need to be reviewed, with the ETCS software development being one of the key elements, as that is essentially going to provide that determines the braking characteristics of the train, which is vital to a system like ETCS. ETCS itself also needs to interface with the train, so as I said before, the system can apply the brakes, it can cut traction power, and it also might need to talk from one cab to the other and across a coupler, so there's obviously that interface requirement there. As with any system like this, there's some quite rigorous RAMS safety and authorization requirements. ETCS is a SIL4 rated system, and so it's defined by those laws and standards in that respect. Pulling us back to the cab design itself, so obviously there's the movement of components on the desk and how a driver interacts with them, but also we need to look at things like glare, audibility and distinguishability, so to make sure that if there is low sun or there's sun shining through the window, can the driver still read the DMI? There has been some operators on ETCS deployments who've had to change things like uniform because it sort of reflects and glares onto the screen, which is obviously not a good thing. And then the final bit there is around audioability and distinguishability, as ETCS provides both visual and audible alerts to inform the driver that they need to react and respond. We obviously need to make sure that those sounds are set to the correct level and that they can distinguish them over other noises in the cab and ambient noise. Put route availability and weight on there. The weight of ETCS components isn't that significant. However, if you already have a vehicle that's the top end of its sort of route availability weight rating, potentially your ETCS solution might impact that. Also, as soon as you talk about installing things like GSMR antennas, GSMR radios, you have to consider things like gauging too. And finally, as with any kind of sort of system of this kind, cybersecurity is obviously a vital component where we need to make sure that a cybersecurity assessment is done. We need to identify potential risks, threat vectors, risk assess it and appropriately mitigate all those elements. So at that point where the design phase is all finished, the design is frozen, we then move on to the first in class phase. So this is when we'll take a single unit out of service, and that will be essentially our prototype. At this point, the supplier will install that ETCS equipment mentioned before onto the train, and following that there'll be some static and dynamic testing. Dynamic testing typically is slow speed, typically on a depot, but it's also line speed testing as well. The photo on the right just shows some depot testing that was done for the Class 7 units there, just to check that the components, for example, the release antenna will read the information in the releases, the movement authority within them, and also the train responds as appropriate. When it comes to dynamic testing at line speed, you typically, or you obviously need a test track for that, and therefore most fitments will go through the Rail Innovation and Development Centre at Riddick Melton. So that's where you'll do your dynamic testing for your fitment. Once all that testing has been done, all the evidence is gathered, reviewed, and that then forms part of the safety case, which forms part of the technical file, and then so that confirms that the components work. But then essentially, to then get that train onto the network, you'll need to do some ETCS system compatibility checks. So that will prove that the train is compatible at a GB network level. But then, as and when the ETCS infrastructure where route specific, you shouldn't have to do any more testing, but there might be instances where you do. We're being told that we can do all the ETCS system compatibility checks in the lab environment. However, if we can't, there's obviously the requirement to do that on the main line in signal protected zones, which are sort of very logistically challenging, expensive, and to use. So once all that's happened and we've got the technical file, we can then achieve APIS, and it's at that point where ourselves as operators will hopefully be able to get a hold of the train and do some operational proving and shadow running. This is vital to validate our processes and any changes to our SMS, but it also provides assurance and confidence, especially when we get to a point when we're trying to operate these trains on the ETCS fitted network. We want to make sure that the system can handle the number of trains that are expected, to make sure there's enough GSMR capacity for them, and that will form part of that. Also during this phase, there'll be the ETCS supplier will validate the design modification procedure to make sure that the design is correct for the fleet fitment, and then we'll obviously make sure that we agree and hand over those units and accept them back to into our fleet. So the next two slides will just try and give you a flavour of all the different laws and standards. I say all this list is by no means exhaustive, and it just sort of shows you the different standards that an ETCS system has to comply with. So right at the top we've got the railway interoperability regulations. So these are originally created by the EU and innovated into UK law, and this was all around having an interoperable system where a train or a subsystem could move seamlessly across all of Europe. that essentially sets the specification for ETCS. There's obviously ROGs, the common safety method that we need to comply with, and then below that we've got the National Technical Specification Notices. The key one to pull out there is the Command and Control Systems, CCS. This determines what ETCS system version the train needs to be installed to, so that's a very key one there. We then move on to National Technical Rules, so obviously key ones to pull out there are how the ADAS and TPWS interfaces with the ETCS system, how information is displayed to the driver via the DMI. We've then got rail industry standards, and finally just for completeness just some European standards that we also need to comply with as part of how we get the system authorised onto a train. So authorisation and approvals, so just pulling out a few of those requirements there, just to say there's a whole lot of evidence and third-party assurance that needs to be done to ensure that we've got a technical file that we can submit to the ORR, which can then allow the train to be approved and authorised into use. In terms of independent assessment, we have to use designated bodies, approved bodies, and also in terms of the common safety method, ASBOs, to check the process has been followed correctly. So achieving APIS is a significant milestone in any project. However, it's only, as an operator, the start of the joys that ETCS brings in a way, because we'll have one fitted unit that's now able to be used in service. However, we then need to try, before we can use it into service, we need to make sure that drivers who encounter that vehicle have been trained how to use it. Even in that first stage where we're still using ADAS and TPWS, we need to train a driver how to do a start ignition, so how to log into the train, set it up in that level, and also what to do should there be any issues, so how to reset the system and how to isolate it. So then we get into this sort of challenging sequencing where we need to make sure that we can get through our driver training in line with the fleet fitment, so that, as I said, we can prevent any cancellations on the day with drivers turning up to trains they're not competent to drive. So just to round up this section, which is more generically how we're approaching ETCS, some of the challenges that will face any fitment project are around test track availability. I mentioned Riddick Melton, that's the only site that I'm aware of that we can really take units to other than the main line. As any parts of the railway, that is prone to the challenges around climate and weather that the rest of the railway is. Changes to standards is quite a live and ongoing issue that we're going to have, because standards are updated rightly. However, once you're already in contract and you're already in sort of working on your project and design phase, you have to review every change of standard and make a decision whether you need to implement any changes or any relevant changes to a standard. There's obviously cost and programme implications there. It's about deciding what is the right decision with respect to them. Another challenge is the variance between onboard solutions and trackside deployments. So each ETCS supplier has interpreted the ETCS standards in a slightly different way, and therefore they aren't immediately the same if you walk from one supplier's train to another. This is something that we're really keen to minimise and where possible influence more standardisation in approach, because we potentially will have drivers who will be driving a Siemens on board, for example, and they might have to drive an Hitachi's on board all within the same day. Beyond that, train drivers do move from company to company, and so they might need to move to another company, and we need to make sure we don't set up any traps in terms of how they interact with the system and sort of any changes there. I talked about the matching the driver training with ROS competency, but I think the final sort of challenges there is just to mention that as a train operating company, our focus is on delivering the train service every day, and therefore we need to make sure that we can support an ETCS rollout in terms of can we supply enough units, can we supply enough drivers and training demand to do so. So not all challenges, there's also some definite opportunities with the rolling stock upgrade projects. Is that it's a great opportunity for trade union engagement to get them involved from the start as we part of the change. We're not the first operator who will be introducing ETCS, and from a lot of the platforms we won't be the first solution that's out there, so therefore we can obviously build on previous operating experience, learn any lessons there. And I think it's really key that you use any opportunity to take staff and colleagues to see the system in action, and also, even if the infrastructure dates are sort of into the 2030s, having a fitment programme that's progressing and getting people involved with things like design and fitment, that can really maintain advocacy and build momentum for our transition to the digital railway. So that's the generic case, but actually what are the trains that we actually operate in TPE, and how will they be impacted by an ETCS upgrade? So currently we have 3 fleets with Siemens Class 185 DMUs, we've got the Hitachi Class 802 bi-mode units, and we've got CAF 397s. We're also procuring some new trains at the moment, funded by TRU. And I just noting that it's the Class 185s and 802s that will operate on the TRU digital infrastructure. Okay. And then one in particular I'll just pull out and mention is that with regards to our Class 185 fleet, we have a contract with Siemens for them to fit ETCS onto all 51 of those units, so taking us through that full process. The plan is that the upgrade will take place at Ardwick Depot, and we're currently in design phase with Siemens on that project. So hopefully in the next couple of years we'll see some ETCS fitted 185s operating on the network. So the final section of my presentation was just to go, so we've talked about the technical trains that is ETCS, but actually how we're going to deliver it as part of TRU, and what's our approach in respect to that. So a bit of a common theme is a case of we need to learn from experienced operators and those who've gone before us. We need to make sure that we follow industry best practice and guidance. So when it comes to driving an ETCS fitted train, we're following the RSSB risk-based training needs analysis process, which is set out for the training of safety critical tasks. We're going to phase that training burden as mentioned, so start with level NTC, get that business resilience, then move on to ETCS level 2. We need to manage the overlapping training demands, as we're not the only project within TPE. TRU as an infrastructure project is changing the railway in many ways, so our drivers are forever being briefed. We need to make sure that when ETCS comes that we can sequence our training needs, so we're not putting our drivers through too much change at any time. We can't just expect that our current training capability is sufficient to deliver ETCS training, so we need to have a look at upskilling and improving how we deliver training. And we need to really establish how we're going to write, agree, safety validate, peer review our training material to make sure it's fit for purpose. A key element to delivering ETCS is the use of simulation, because you can't recreate degraded modes, for example, on the main line itself. So we're obviously looking at the use of tablet simulation, ETCS desktop simulators to support that. And then finally, it's really important that we communicate and engage with all our staff who are impacted and wider to make sure that they're aware of the change that's come in, they get them interested in that respect. So finally, a couple of slides just to summarise what the plan for TRU. So we'll upgrade our current fleets with ETCS, get them into level NTC operation. The new trains that we're procuring will come with ETCS, and obviously get them operating on the conventional railway. I mentioned before we need to teach drivers how to operate in level NTC. At the appropriate point, the TRU programme will then deliver ETCS infrastructure onto the route, where, so, as I said before, we're going to have the conventional signal with the digital signal on top of it to facilitate driver training. It's at this point we'll take our drivers on a more extensive training programme where it will involve classrooms, simulation and practical handling, where they'll learn how to drive a train in ETCS and then also how to operate it in degraded modes. Just a few pictures to say, even though that's some years away, in preparation for that we have been visiting other operators, we have been seeing what simulation solutions out there, and so there's VY and the Netherlands National Railway, I can't pronounce the NS. We've obviously visited them to learn from them as they're already using ETCS. Finally, once all the trains are fitted, all the drivers are trained for all operators in TRU, those colour light signals will be removed and we'll have an ETCS signals away railway, and that's when we get the full benefits of the TransPennine route upgrade programme. So final slide, just to try and summarise and bring it all together. So why are we doing it? So ETCS provides safety benefits. The railway is unreliable, so the ETCS system should be more reliable than what the railway that we've got today. Re-signal and maintenance costs are high and unsustainable, and so the railway is congested and the current signal provides performance and capacity constraints, which I touched on before. At TPE, we're going to approach the change to digital signalling safely in line with all laws and standards. We need to work collaboratively with colleagues and trade unions. We're going to do this in line with the industry because ETCS brings track and train as close together as it's probably ever been. And also we need to make sure we develop internal capability, as there aren't just loads of ETCS competent operators and engineers available. A lot of them will be working on ECDP anyway, so we need to look at how we develop and grow that capability in-house. And just the column on the right just shows all the colleagues and stakeholders who will be impacted by ETCS. That's all my slides, so thank you very much for listening, and I'll happily take any questions.
Okay, great, thanks, Sean. Thank you. Okay, who would like to start us off? Some applause from the online audience as well. Okay.
Two questions. Do the track releases facilitate from the direction of the track? And the second question is, if you have a train, one of the critical items on the ECTS, what's the degraded route? How do you overcome that? If you remove all the lights on the sticks, how does the train proceed?
So my understanding is, yes, so bleeders can be read in either direction, and what we understand is that bi-directional is a lot easier to do in ETCS as opposed to doing it today with conventional signalling. The second part of the question was in terms of degraded mode. So we mentioned quite a bit around the authority section of the train. If a train can't perceive the authority, for example, the GSMR network went down, etc., there are a set of procedures, they're called written orders, which a train driver would agree with the signaller, as in there are modes on the system that allow the driver to move, they don't give them authority to drive to a certain point, and so there are procedures that will allow drivers to recover in those sort of situations.
Okay.
Could you elaborate, please, a little bit on the automatic power changeover, or maybe non-automatic power changeover and so on? I'm assuming that because we're here up north and we don't deserve the funding, so we've got, bits that are not electrified yet and probably won't be for a while, so you're going to have a big power changeover. Have there been any sort of like close shaves or whoopsies or whatever? How does that look?
So we currently use the TPE class 802s currently use automatic power change over on the route. So where the line is electrified over the Pennines, they'll use electric. I understand from sort of Liverpool, Manchester area. Then there's automatic power changeover there. So that works in the system does it itself, and then there's a zero release. My understanding is the zero release will then make sure the pan drops in time. So it's quite an established system that TPE, LNER, Hull, Lumo, they utilise that system. Use that system. In terms of what the link is into to ETCS, is ETCS information is sent by packets. One of the packets available to be sent is something called packet 44, where the system, the bleeds antennas can read Belize information, and packet 44 information is information that's non-specific to the ETCS train control bit. So what the train does, it will read the packet 44 automatic power changing over information that says put the pan up, put the pan down. It can then feed that into the train management system on the train, and then that will allow that train to automatically change its power over.
Howard.
Hello.
What's TPE's strategy for dealing with cyber security OT cybersecurity?
So cybersecurity, there are the sort of requirements and guidance that we need to follow, like the I can't remember off the top of my head, but like the NIS, and it's what we contract with our suppliers to carry out the cybersecurity assurance case and activity there. Once that's been provided by the supplier, then it's as ourselves as an operator to then carry out our assurance to make sure we're satisfied with that, to make sure that mitigations have been put in there. Within the industry, there's obviously the need to be better in terms of cybersecurity is being raised, and I know in the sort of the RSSB space and sort of standard level, there's work being going on there. A lot of it around making sure that we've done everything that we can during the design and the actual fitment, but then making sure we've got the right processes in place that should we get a cyber attack, we know what to do, the process is really clear and defined and how to react to it.
Thanks, John. It's really interesting. Lots of good points. I've just got a question. It's more of an operational one. But everyone focuses on the changes to the driver because obviously that's a big change.
Yeah.
But I was wondering, and this will affect TransPennine as well, but with longer trains and trains that have curved platforms, we use dispatch staff on stations, and the first thing they do is look at the signal and then start the dispatch process. How is that going to work within the TCS?
Yeah. So apologies in the sort of in the flow I didn't go to talk about then, but yes. So in terms of ETCS, whilst we've got some low NTC and we've got signals there, the assumption that the dispatch process will remain as it is today. However, obviously, once we start to remove signals, and the dispatcher then doesn't have a signal to look at to say the route ahead is clear. I think so that work's been conducted at an industry level exactly how it's going to work, but the assumption and what we've been told is that there will be off indicators provided for dispatchers in those areas. Yes. So that's what we've been told. They haven't completed the work yet, but that seems like the direction that things are going. The alternative is, I think, what they understand on the Cambrian line, so where they've got where they've got train managers guards there, is that they have to the guard has to confirm with the driver that the driver's got a movement authority, and then which obviously adds into the dispatch process. So in summary, it's being looked at a national level because on ECDP we're going to have operators with dispatchers and locations with dispatch staff there, but the assumption is that there'll be some kind of off indicator or some kind of indication given to those dispatch staff to then understand how to dispatch a train.
How is it the 397s are clear about the equipment installed in the road? Something known about at the time.
So I wasn't around in TPE at the time for them, so I can't answer that question.
I think 397s are ETCS ready.
So there's provision for it on there, but yeah.
Okay, yeah. There's a significant amount of new kit on this track. What effect on reliability and what impact on preparing the train for service?
So I think in terms of reliability, so I think with any modification, I think there's the anticipation there'll be the bathtub curve, that there will be some initial issues. Some of that will be the actual integration itself. Some of it will be sort of user error there. As it's a sole force safety system, personal view is that it's pretty good at saying it either works or it doesn't work. It'll either allow you to move the train or not, and there's a lot of the self-tests within it. So in terms of preparing the train for service in the day, either a train driver or a maintainer would carry out a train prep. Doing that, it will probably be a starter mission, and the system equipment tell you if it's working or not. In that respect.
You talked about the equipment that's going on the train.
Yeah.
The interface between the trains and the control center while you're signaling information.
Yeah.
How is that going to be effective? Who's responsible for it? Who's doing the integrity analysis? Looking back at the camera, near miss, big near miss on the Cambridge
Yeah.
was when the central computer system failed to break overnight, right?
Yeah.
There were no temporary speed restrictions displayed to any of the trains. It was only pointed out by one of the drivers communicating with the control center saying, what's happened to speed restrictions? And then, immediately, it was then found out that they hadn't been loaded down into the system. Worse than that, the railway continued to run. Shouldn't be stopped. So, who's doing the integrity work for that? That's what we should do.
So it's that case is obviously well known in the ETCS community, and I'm sure on the infrastructure side, they're all over it, for want of a better term. In terms of who's responsible for the deployment of the actual infrastructure, so I understand on ECDP it is Siemens, for example, and what the industry's just done, they've announced that is a train control supplier framework, I believe it's called, which there are 4 suppliers on there, so Siemens, Alstom, and there's Atkins and Carth and another one, and so it would be their responsibility to implement it. As to exactly who's assuring against that specific item, it's not something that we're aware of at the moment. We're not at a point in terms of the TRU programme where the supplier has been contracted and we are able to actually sort of ask those questions, but it's a good point. But I sort of personally feel that it's well known about instances that the railways very keen not to let happen again.
It seems that in terms of total system risk analysis, there's a gap here. People putting stuff on trains, people doing something in the control centre.
Yeah.
As operators, you have a responsibility to make sure that integrity is that system. But I don't see anything happening in that regard in terms of putting together and following some common standards.
Within the compatibility process, there is and all that work that I sort of put on there. There will be the transfer of hazards and all that assurance work and sort of industry panels at which will determine whether a system is safe to go into service or not. So it will be at that sort of panel where those sort of things will be discussed.
Go to the online. Go on, now go to the online one.
The cost of the corridors, obviously, that I know, Thames have been working on looking at quite automatic train operation through there.
Nothing that we're looking at involves automatic train operation. As I say, we're mainly focused on the TRU digital upgrade, and then they follow that. We've been told it's the West Coast Main Line, but I do know the national digital portfolio has a plan to upgrade potentially all the lines in the country of ETCS, so potentially when it comes to that point, who knows, but yeah, it's not something we're aware of.
Okay, I'll see if the online audience can stomach on some of these. Which onboard unit supply has been used? One question. Which onboard unit supplier is being used for the ETCS equipment?
So so the contract we've got with the Class 185s is a Siemens. So we've contracted Siemens to supply the onboard equipment for the 185 needs.
And which baseline is ETCS being installed to? Is it different to 3.6.0 as on the East Coast?
So we contracted the 185 pregnancy for 3.6. So baseline 3 release 2, system version 2.1.
It says here the East Coast Digitalisation Programme is conducting system testing to ensure the infrastructure can cope with the different onboard units and volume of trains. I assume that TRU will have to do the same.
Yes.
Yeah, exactly. Yes.
Yes.
What's driving the need to train drivers in the level NTC, then level 2 with signals, then level 2 with no signals? This would increase infrastructure costs, presumably. Why not just go from conventional to ETCS level 2 from day one?
So the reason why we have level NTC is required to operate that ETCS fitted train. If you were going to introduce a train with ETCS on it onto a ETCS level 2 railway, you would just put the training together, so the training course would just be extended to include how to operate on an area that doesn't have ETCS on it. The reason why we need to have that ETCS level 2 with signals is because you can't train all the drivers overnight. We've still got to run a train service. We can't have cancellations while we wait. So I think parts of the Cameron deployment, they were able to shut the railway and bus all the passengers for a while. When you've got sort of main lines such as TRU, East Coast Main Line, West Coast Main Line, you can't really shut the railway to give you that critical mass of training of drivers so that you can then just go straight to level 2 without signals. But I think the TRU programme is part, so as the ECDP is part of the national rollout strategy. So hopefully, because TRU is where it is, and there's a large number of drivers for TPE, Northern, cross country, etc., that you'll do a lot of the training at that point where you can go to a signals away railway. Once you've got a signals away railway, it's easy just to get drivers to drive on a signals away railway. But we need the level 2 with signals to get us to that critical mass of drivers to then allow us to get to that migration.
Simulator training wouldn't be feasible.
So many people say many people say practical handling is really bad and that we should do everything in simulators. But then, when a driver's practical handling on a train, they're physically driving a service train. So that train's in service. If you need to take them off that train and put them into the simulator, you then need another driver to drive that train. So it isn't a silver bullet to deal with the driver training demand.
This is a little bit of a thinking out of the box sort of question, more of the lessons learned. The rail industry faces many challenges, including reducing the cost and time to introduce ETCS. If you could change anything in the processes in order to reduce costs, do things quicker, what would it be? Tricky one.
Reduce costs. I think as I sort of mentioned, that the standards do change. So there's a question there about what baseline we're operating to. So the infrastructures are baseline 3 release 2. The trains, so the current RIS says it's baseline 3 release 2. From the TSI in Europe and then into the NTSN in the UK, baseline 4 has now been introduced. So the sensible thing in my personal view is that we stick with 3.6 for a period of time, so that we can get to that certain level and then we go from there. So that's one thing. It's just that yes, standards need to be updated, but how do we do that in the most efficient way? The other thing is to minimise sort of optionality, and so one of the things we try to do. So, for example, we've got a Hitachi train there. Hitachi are working on an ETCS solution for LNER. It makes sense that, because our trains are very similar, that we'd have the same solution there. So anything we can do to minimise divergence, repetitive sort of testing and validation opportunities that we need to look at and do.
Okay. Here's one that I'm quite interested in. How will you distinguish ETCS system on board failures versus trackside failures in the event of the system failure? Is there going to be a way of determining quite quickly which bits?
So what a lot of the text messages and information provided to the drivers, that is consistent. So the messaging that they're given, that's all defined by standards, so that will give an idea. More and more trains have things like remote condition monitoring, where you might be able to monitor live the signals between the ETCS system and the train. And there is a lot of focus on a DRACAS system. Forgive me, I can't remember exactly what the acronym stands for, but they're piloting it on, well, there's already one on Thameslink. They're using it on ECDP, but essentially it's a defect reporting and analysis system that they're going to use. So as soon as an issue is raised, it can then be quickly apportioned to whether it's an onboard or trackside. Is it a system-wide issue, or is it just bespoke to one specific location or train? So that's stuff that the industry's working on at the moment, and stuff that we're already contracting our suppliers to support with.
TrackCast is the nationwide system for monitoring ETCS.
So there's a national DRACAS which is all CCS, so that would include AWS and TBS2. That's so the national DRACAS. There's one set up on ECDP that we expect will then become the national DRACAS that we all work into.
Okay, I think you asked a question on cybersecurity, because we've had a couple of cybersecurity before. There's an additional one that says, how will you address areas with poor GSMR coverage that might have some blackouts or GSMR?
So I think that's comes similar to the point of there. So that's some of the levels of assurance that we want from the infrastructure deployments, is ensuring that there is sufficient GSMR coverage there. And I am aware that it's part of the TransPennine route upgrade that they will cover ensuring there's sufficient GSMR capability there. If there isn't, it will cause issues. Obviously, loss of connection with the RBC, but I think at this point, the expectation is that is, with the deployments, they cover the coverage and make sure they're sufficient for the amount of trains that need to operate on the line.
Additional question for myself: how does it work in the tunnels then, like Standish Tunnel, Morley, Batley, and the long tunnels, or do you not need GSM? There's no authority through that tunnel.
If I'm honest, I'm not sure. To be honest, I don't know exactly, but I think I think the trains can still operate without. So if I know, I think the Cambrian might have definite points where GSMR coverage is poor. I think trains can still operate in certain circumstances if you lose GSMR coverage momentarily, but yeah, I think they can. I'd have to get back to you fully on how we deal with the problem with tunnels. Yeah.
Well, no doubt we will. It feels like there'll be a sequel coming along in the future.
Yes, no,
so
happy to
you're
do
more
so.
than welcome to come back and present when it's all up and running at some point. That'd be great. So yeah, just thank you for that. I'd like to invite Chris to do a vote of thanks on behalf of the institutions.
First of all, congratulations on having the courage to stand here and pitch about ETCS to fellow members of the IRC. It's a very challenging thing to do, especially when it's their day-to-day pretty much. And I think you just fielded the questions very well there, considering how complex and difficult they have been. And I can guarantee not one person has all the answers. It's great to have a presentation that almost makes it look so easy, but also revert quite quickly back to how complex it is to get all those standards and integration problems you are going to face and you're already facing. I think it really infuses me to see a train operator talking about ETCS, because it means that falls there. It's such a challenge trying to get the trackside element in when you said, oh, we need the train walk to be complete first. Well, it's going to be there a lot quicker than what we're prepared to do. And your strategy aligns nicely with the Network Rail's plan to have a possible understanding maybe what they might in the future want to do with ETCS in 2029. And all those possibilities would be nice to see. Hopefully more along that. I'll touch on one of the key points. You're not the first to do this. There's been many mistakes made before. So those that have been involved, please share your experiences and your mistakes so that we can continue to learn and grow as fellow kind of rail enthusiasts and members of the industry. It's the mistakes which we fix and then that makes us good engineers. But one of the big ones is you won't be the last either. So yes, as Alden said, please come back. Show us how it went, even if it is in 2029, 2030. Let's see it all working perfect. And who knows, in 60 years' time, maybe we'll be sat in the audience asking some of the same questions in the next generation signaling system like that, or even But from behalf of all, thank you for a really good talk. And if you show our usual appreciation.
Thank you, John, and thank you, Chris. Yeah, some notices now. The next lecture